Hello again. Thanks for joining us on this, yet another edition of Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, your host. Great to have your company. Coming up on a fresh episode, Artemis 2 making headlines for all the right reasons. What a sigh of relief that was. Did you watch the launch? I sure did. But some bad news for the Australia ESO deal, which has got astronomers upset. One in particular I can think of. What's his name again? And the discovery of an X-ray binary. That's all coming up in this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Just wondering what an X-ray binary is. It sounds like something you could get arrested for. And joining us to talk about all of that is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. And I pick you up on that because I nearly got arrested once for doing astronomy with an old brass telescope in the front garden, which the neighbours thought was a bazooka. And so I had a visit from a very large policeman. I think I was 16 or 17 at the time.
Because these days you'd get accused of being a peeping Tom or something. But back then they thought it was a weapon.
The reason why I didn't get...
They do have weapon-like, looks
they do.
them, don't they?
Yeah, they look like a gun. That's right. The reason why I didn't get any complaints about being a peeping Tom was that our front garden overlooked the cemetery, and there wasn't anybody around to complain.
Okay. Lots of things come to mind, but I'll just
Yes.
I won't go there.
No, don't.
Yes, when was that?
The early 1960s. Yeah, not long after the Second World War, which is why bazookas were on people's minds.
Yeah, everyone was still super sensitive, I guess. Fred, it's been an exciting week. I know this is a podcast, so some people will hear this well after the fact, but the other day, Artemis 2 lifted off very successfully, which was very, very exciting. And I watched it live on NASA Live, which a lot of people did. There were tens of thousands of people logged on, and the system held up. And I just watched the whole thing. I had it on my computer. I sat there and I watched the whole hour build up to the launch and watched it all unfold. And it went something like this.
10, 9, 8, 7. RS-25 engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis 2 now bound for the moon. Humanity's next great voyage begins.
How cool is that? How cool! And those engines, the sound of those engines, even over the internet on a shonky microphone, because NASA can't really afford good stuff. No, it sounded. You want to hear that again? That just the sound of the engines. Okay.
Why not?
Yeah. All right. No, that was just me blowing into the microphone. But, fantastic stuff. It was so exciting to watch. I really got a big kick out of it. And you could hear the crowd cheering at one stage. It was so loud that the microphones picked up the crowd. And, it was an amazing moment. And, of course, as we speak today, they have reached the moon and done their lap. They went onto the dark side, and all that LOS talk was being spoken of with loss of signal. I mean, they were blocked out by a big rock, and they achieved so much. I think, it's been a pretty exciting week, hasn't it, Fred?
You can say that again. And that live broadcast that you're talking about, I've still got it on in the computer.
I've had it on this afternoon.
Yeah, we're getting updates all the time. And, this is kind of NASA at its best, isn't it, really?
Yes.
It's just such a fantastic achievement for us to see this mission going so profoundly well. You said the traverse behind the moon has taken place now. There was a 40-minute loss of signal, which you'd expect for exactly the reason that you mentioned. The moon is a big rock and gets in the way of radio signals. But also what the astronauts on board Artemis saw was an eclipse of the sun. So the moon's disk actually covered the sun. Now, from our vantage point on Earth, the sun and the moon look to be the same size. It's one of the most curious cosmic coincidences that we've got our satellite and our star, which have the same angular size, half a degree in the sky. But of course, from the vantage point of the Artemis astronauts, who are roughly 6,000 kilometers from the moon's surface at the moment, the moon is a lot bigger. And so, yes, they did see an eclipse. And as the moon covered the disk of the sun, they would see, first of all, the inner atmosphere of the sun, what we call the chromosphere, which often has pink glowing clouds of hydrogen on it. But more especially, they would have seen the corona, the sun's outer atmosphere, which is what captivates eclipse goers whenever they go and see a total eclipse of the sun. And I can't resist there a plug for 22nd of July 2028, when a total eclipse of the sun will see the moon's shadow passing over both where you're sitting at the moment in Dubbo and where I'm sitting at the moment in Sydney. That's going to be a huge event. Perhaps not quite as momentous as seeing it from a spacecraft on the far side of the moon, but still pretty good.
Yes.
And, the astronauts are indeed now on their way home. They, in a sense, they've been on their way home ever since they left Earth orbit, because the trajectory that the rocket was inserted into, the translunar insertion move, which took place above the Earth's surface, that really placed them on a path that inevitably would take them in a figure of eight loop around the moon and bring them back to Earth. Now, there are mid-course corrections. I think there is one planned for later today, after which I think the astronauts are going to be given some time to themselves, because they've been pretty hard at work in the last 24 hours with the lunar far side flyby.
Absolutely. They've achieved so much today. The four astronauts, Reed Wiseman, Victor Glover, Christina Koch, or Koch, depending on how you want to pronounce it, Jeremy Hansen, have become the first humans to go beyond where Apollo 13 set the record for the furthest distance for humans from Earth. So they are now world record holders. Is it a world record when you're not on the world? I don't know.
It's a solar system record.
Yes.
Yes, indeed. The distance 407,000 kilometres from Earth, which, and I think it was about 400,000 that the Apollo 13 astronauts flew at. So it's a significant increase from that, more than 6,000 kilometres.
So the most isolated humans in history, in real terms.
Yes, that's right, in a sense. And they probably felt like that when they were out of communication for that 40 minutes, when they were in the moon's shadow from radio signals from Earth.
Yeah. And while I was listening to the live broadcast this afternoon, our time, I heard them talking about seeing meteorite flashes on the surface of the moon. They spotted 4 impacts while they were rounding the moon, which I find astounding. And it was really exciting for everybody, especially the science team that were talking to them at that moment.
Now, that I didn't hear, so that's great. Yeah. That's great.
Yeah, quite incredible. Yeah, so things are happening that you wouldn't. And apparently where these impacts happened, people on Earth who were observing the moon at the time may well have seen them too. Mm-hmm. So I don't know if it's just a coincidence. We just happen to have a spaceship right there at the time, or this happens a lot.
I think it's happening a lot. I think that's the bottom line. It's these things have been observed actually since the 1950s, when they were called transient lunar events, which we now know are, as you said, meteorite impacts. I also noted that 2 relatively fresh and unnamed craters have been given a name by the astronauts. One is Integrity, which is the name of the spacecraft, and the other is Carol, which is the name of Reed Wiseman's late wife, who died a few years ago. Yeah,
that's so
lovely stuff. Yeah.
Yeah, and more to be written, I suppose, as this mission unfolds.
Absolutely.
And so far so good. And a whole new generation feeling the same excitement we did back in the 60s and 70s when the Apollo missions did exactly the same thing. This This flyby is probably a replication of Apollo 8, I think.
Very much so.
This?
Yeah, very similar to Apollo 8, December 1968. I remember it well.
Christmas Day, wasn't it?
It was, yeah, that's right. Christmas Eve, I think it might have been, but it depends on your time zone.
Yeah.
It's just sort of occurred to me a couple of times. I'm kind of rambling a bit now, but in perhaps a quasi-Trumpian manner. But I think it's really interesting to me because my career in astronomy, my working career in astronomy is kind of bookended by lunar missions because it was early in my career that we were watching all the Apollo flights, and I don't think anyone, even with the best will in the world, would deny that I'm now late in my career and we've got the Artemis excitement coming as well. It's just great stuff.
It is fabulous stuff, and you can read all about it or even watch it live as it happens, which we really couldn't do back in the 60s and 70s. Not like this. We had to rely on television. But now you can just log on to NASA Live and watch it all happen in real time. It's fantastic stuff. Yeah. So more to talk about down the track, I'm sure. But if you've been following it, well, you probably know more than we do. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a short break from Space Nuts to tell you about our sponsor, NordVPN. Now, I've talked about virtual private networks before and how they can protect you online, and no one does it better than Nord. Now, I've been using Nord for over 2 years and I have no complaints. I'm also using some of their other tools, including the brilliant password manager. NordVPN is great for streaming and won't slow you down. In fact, it does the opposite with no interruptions, no limits on bandwidth and no limits on speed. Right now, using the exclusive Space Nuts offer, you can receive 4 extra months for free on a nordvpn.com plan. NordVPN encrypts your internet connection, hides your IP address, and offers access to over 7,700 servers around the world. Plus, with features like Threat Protection Pro, MeshNet, ultra-fast speeds via Nord links, your digital life stays private and efficient. So don't miss out. Visit nordvpn.com/spacenuts and enter the code SpaceNuts to claim this deal. Remember, there's a 30-day money-back guarantee, so it's risk-free to try. Stay safe, stay private, and browse with confidence. That's nordvpn.com/spacenuts.
The crew of Artemis 2 now bound for the moon. Humanity's next great voyage begins.
Space Nuts.
Now, Fred, we go from excitement to something quite upsetting for Australian astronomers, including yourself, and that is an announcement by the Australian government to discontinue the deal with the European Southern Observatory. It's all over Red Rover by the sound of it.
Yes. We still hope for something to come out of all this, but the backstory here is that Australian astronomers since 2017 have had access to the best telescopes in the Southern Hemisphere, without question, the best optical telescopes, anyway, visible light telescopes, which are operated by the European Southern Observatory, whose headquarters are in Munich, and whose telescopes are in northern Chile. And those, principally the biggest telescopes are the 4 8.2 metre components of what's called the VLT, the Very Large Telescope, which have been which Australian astronomers have had access to since 2017, and has been a highly productive arrangement, not just for the astronomers, but also because our instrument builders here in Australia, the people who build the fancy instruments that go on the back of telescopes, have excelled themselves with what they've achieved because of the opportunities to build kit for these giant telescopes. So, and plus all the spin-offs in terms of education and STEM and outreach and all the rest of it, which we've tried to capitalise on. But that partnership was always going to be a 10-year deal. So 2017 to 2027, it comes to an end in December next year. And we in the astronomy community, I started worrying about this actually in 2018, what was going to happen next, and to make a case for the next step, which would have to be, according to the rules of the European Southern Observatory, would have to be full membership. And that is the stumbling block, because whilst 10 years of strategic partnership were valued at 129 million Australian dollars, 10 years of full membership is $400 million, nearly $500 million. And that is something that governments don't like, big numbers like that. And especially in times of financial stringency, which we understand. However, we do think that the government could have looked rather more constructively at other possible opportunities before making this announcement, and there may be still scope for that. We've discussed things like Australian astronomers making in-kind contributions to ESO, European Southern Observatory, by, for example, building instruments, including the possibility of a new telescope here in Australia that could be actually installed in the site, near the site where the VLT, Very Large Telescope unit instruments are situated, at a place called Cerro Paranal. Perhaps the most galling thing about this, though, Andrew, is that we have our membership, if we were to become members of ESO, would give us access to what is going to be the most stupendous telescope in the world when it comes on stream early in 2029. That is the European Southern Observatory's ELT, or Extremely Large Telescope.
Telescope. Sorry, what?
That's the one. That's as good a title, because that's what it's going to be. 39-metre diameter mirror. The mirror diameter is 10 times that of the biggest telescope in Australia, the Anglo-Australian telescope that I used to be astronomer in charge of. It's 10 times bigger, which gives you 100 times the sensitivity in terms of light gathering power, and plus many other benefits. That will come on stream 2029. It is sure to generate Nobel Prizes. Australian astronomers will be barred from that. And the great pity of that is that Australian astronomers have access to the Square Kilometre Array, which will come online at about the same time. And to have those two things together under the auspices of Australian astronomy would have given them a head start over the whole world in terms of discoveries, because the two things absolutely dovetail together, the SKA and the ESO ELT. That is not now going to happen, and we feel that's a wasted opportunity. And I might just add one more thing, if I may.
Oh, yeah, please.
Because this is something very close to my heart. I've worked very hard on this for the last almost decade. There was a report that came out last month, written by one of the country's senior economists, a man named Professor Richard Holden, and he's at the University of New South Wales here in Australia. He has done an analysis of the economic benefits of astronomy, not just about, the deals that you can do where you get money to build instruments and things of that sort. It's about the value of ideas, the spin-offs that we have. All of those things are taken into account in a report he wrote, and he makes the point in conclusion in that report that Australian astronomy adds about $330 million per year to the country's economy, which makes $40 million a year for the ESO deal seem really quite proportionate. There will be a huge return on that $40 million in terms of other benefits. And that's what the government's missing out on.
Yeah, I think when we talked about this a few episodes ago, because we knew this was coming up, I said something flippant like, the left hand probably won't know what the right hand's doing. So the cost benefit versus cost, the benefit versus cost analysis may not get on the right desk and the decision could go against you. And I was being a smarty pants, but it kind of looks like that's what's happened.
Yeah, I don't actually. I think it's different from that because we made sure that the people who are making the decisions, and it's not Geordie, by the way, but he makes his own decisions. I don't know whether you heard that.
I did.
The people who are making the decisions had access to that report. We made that very clear as soon as it came out. Now, I suspect that the minister and his science advisors would also have had access to it. So what they've done is they've turned their backs on that, and they've turned their backs on something that is very exciting in relation to our exploration of the universe at the very time when everybody else is looking skyward because of Artemis. We had this news on the day of the Artemis 2 launch. Couldn't have been a bigger contrast between the two stories.
And where does this leave the likes of the Australian Space Agency, for example? I mean, the government's established that, or a former government did, and they've been pouring money into it. Now they've sort of shut the door in your face in regard to the Europe, the
European
work with
Southern Observatory.
Yes, exactly, ESO.
Yeah.
Where does this put everything? Are we kind of going back to the dark ages?
Yes,
pun intended.
No pun intended. No, we are going back probably several decades for Australian optical astronomy. But the Space Agency has been likewise chastised, if I can put it that way. They had a large budget taken off them by the present government about 3 years ago. And I actually wonder if some of this is political, because the Space Agency was initiated by a previous government, and the ESO strategic partnership was initiated by a previous government of opposite flavour to what we have now. Yes. So there might be a political side to it. I'm sure the minister would deny that. It's all about
of course he would.
But,
of course he would. But I've seen politics in action, and I can tell you quite clearly. I'll give you an example. We were going to get a big sports hub in Dubbo. And it was announced by our local member, who was also the leader of his party at the time. And when they lost the next election, the new premier of the opponent party took the money away and said, no, you can't have it.
Yeah.
And that was purely political, just basically to slap an opposition leader in the face. And yes, they would deny it, but that's just the way the game is played all over the world. This is really sad, really, really sad that it's come to this. Any hope, Fred, of some turnaround, some chance of redemption?
There's always hope. I
maybe
think,
not after what I just said, but
it's okay.
I'm not an astronomer.
No. Nobody listens to this. It's okay. Look, I am hopeful. We have some discussions coming up that I hope might emerge, from which might emerge some, perhaps what you might call more affordable options, which might still involve ESO. The problem is ESO has its own rules, and ESO is, I think it's 17 member countries, and if you do a special deal for Australia, they're all going to say, well, why don't we get a special deal like that as well? And that's understandable. So ESO has to tread very carefully in this kind of thing.
Yeah, that makes sense. All right. Well, hopefully common sense will prevail sometime in the next 2 years, and somebody changes their mind and sees the benefits rather than just looking at the dollar signs.
Looking at the dollars, that's right.
Okay. This is Space Nuts. Andrew Dunkley with Professor Fred Watson.
Hey, that's one of the better sims, believe me. We've had a couple of cardiac arrests down here too, Pete. There wasn't any time for that up here.
Space Nuts.
All right. Our final story takes us quite a way away from the planet, a little bit further than Artemis 2 has travelled, in fact. The discovery of an X-ray binary, Fred. Now, I'm not sure what this is, but yes, I know there's all sorts of radio wave type signals flying around the universe, X-rays, gamma rays, AC/DC, you name it. But it's all out there. What is an X-ray binary?
That's a great question, because this is a story about an X-ray binary that isn't a binary. Okay. So just to complicate things further. So what's an X-ray binary? If you've got a star which has got a star a bit like the sun, actually, these are normal stars like the sun, gets to the end of its life, and after usually something in the region of 10 billion years, what happens is it puffs off its outer layers because the nuclear reactions change in its interior, and eventually its core collapses to become something we call a white dwarf star. We've talked about them before. They're about the size of the Earth with about the mass of a star, and they've basically exhausted their fuel. They're still shining because they're very hot. So that's a white dwarf star. Now, often that will happen in what's called a binary system, two stars orbiting around their common centre of gravity. Yep. And a binary is actually almost the most common form of stars in the galaxy. Many, many stars that we observe, almost 50%, are actually part of a binary pair. They're part of a duo. So if you've got a star that's collapsed into a white dwarf star, which has intense gravity, not quite as intense as a black hole, but pretty intense, and it's being orbited by another star that hasn't got to that stage in its evolution, then what you get is the white dwarf is sucking matter off the other star and spiraling it inwards. The white dwarf's eating it up. And eventually, if the white dwarf has enough of that stuff, it becomes unstable and turns into what we call a type 1a supernova, an exploding star. But during that process, while your white dwarf and your normal star are in this dance around each other with stuff being pulled off the normal star, that stuff will be accelerated by the gravity of the white dwarf, and it will emit X-rays because it is being so highly excited by the energy that's basically being imparted to it as it gets pulled in. It's a bit like the accretion disk of a black hole. It's a kind of calmed down version of that.
That all makes sense.
I'm glad it does. That's where the X-ray bit comes from. So an X-ray binary is two stars. One's a normal star having its surface sucked away by a white dwarf, and that sucking away of material causes the X-rays. So that's how you discover it. So what has happened?
But this isn't what's happening now, is it? With this discovery?
No. But that's the backstory, if I can put it that way. Yeah. What has happened now is there are two of them, actually, two stars that have been discovered, which show all the signs of being an X-ray binary in terms of the X-rays that they emit, but there's no other star there. There's no, there's only the white dwarf. There's nothing else.
Okay.
And that means it's an X-ray binary that isn't a binary. And two of these things have been discovered by a group of scientists who actually look for these things. They've got interesting names, perhaps a bit more imaginative than the usual astronomical names. One is called Gandalf, and the other is called Moon-sized. They were discovered at different times, but they're basically, they are part of the same survey. So they've got the signature of X-rays, but no companion object that is basically telling you that it's a normal X-ray binary.
So it's very, does that mean there's something else there that it's feeding off? Or
that's correct. It looks as though that what they have is a half ring of material actually circulating around the white dwarf. So, and that this is the debris from basically a star being swallowed up, another star being swallowed up by the white dwarf. It's very, very odd and very unusual, and quite hard to get your head around this moving ring. which, as the white dwarf itself spins and generates a magnetic field, is not actually aligned with where we think the magnetic field is. So it's a puzzle. I'm going to quote one of the authors of one of these papers, who says, to note, white dwarfs of similar age and evolutionary stage are typically non-magnetic. While highly magnetic white dwarf remnants are already an exception, Gandalf is now only one of only 2 known merger remnants to feature asymmetric magnetization. That's all gobbledygook for saying this is a very, very peculiar pair of objects that we see, and they're in different parts of the universe. They're not related to each other. They are different parts. So this is a really interesting episode, because it looks as though a completely new class of stars has been discovered here, something that really is not the norm, stuff that we know about and are familiar and love. It's just not part of that. It's something quite new.
As you're explaining it, my thought just went to, could this just be the end of the partnership? Like the stars pretty well just, there's hardly anything left. You're still getting that X-ray deal going on, but, there's hardly any material left, and see you later, alligator.
And what's there is spread into half a ring, which seems to be the case. Yeah, I think that is probably the bottom line of this. Which is borne out by
figured something out, perhaps.
You figured something out, yep.
Where's my Nobel Prize?
Actually, I think I've got it here in this drawer. So I put it away last week. Yes, it's it's great that we've got an entirely new category of highly magnetized white dwarf, which is something that's not been seen before.
Yes, indeed. Very exciting. If you'd like to read about that, you can see it on one of the best websites around when it comes to science and astronomy, and that's phys.org, not F-I-Z-Z. It's phys.org, phys.org. Great story. We had a bit of a sandwich there. Good news, bad news, good news, I think.
Yes, that's right. We do our best. We aim to please, don't we? I mean, we're only adequate, but we do aim to please at some level.
We do, yes. Although, depends which part of it you were listening to as to what was pleasing and what wasn't. I think it was self-evident.
Yes,
indeed.
That's right.
We're all done, Fred. Thank you very much.
Great pleasure, Andrew. Always good to air my grievances as well as talk about the latest in science news. We'll see you next time. Yes, we will. Catch you on the next episode, a Q&A episode coming your way very, very soon. And while you're online, have a listen or have a look around on our website, because we'd love you to do that. You can sign up to the Astronomy Daily newsfeed. You can become a supporter, which is totally optional, but there's a little button there. You can send us messages or questions through the Ask Me Anything button at the top. It's called AMA. And please leave reviews at your favourite podcasting platform. They help us a lot, and we really would appreciate it. I think we mostly get reasonably good ones, 2.5, 3 stars. Woohoo! No, we've had a few bigger than that. And thanks to Hugh in the studio. We've just come out of a long weekend here in Australia, and Hugh's been away, and he was running late because he was at a convention of white dwarfs. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.